Welcome to section 5.4, solve compound inequalities. Now, a compound inequality consists of two different inequalities, two separate inequalities that are joined by either the word and or the word or. The word and means both have to be true in order for you to have your answer. Or means that either can be true and your answer will still be correct. Both can still be true with or and it will be true, but we just need either to be true. So this section is going to require us to translate some verbal phrases into inequalities, and then we'll graph them. So let's start out doing that. So we're looking for all real numbers that are greater than -2. Well, we need -2 has to be less than our numbers that we're looking at. Or our numbers have to be greater than -2. You can read that both ways. And those same numbers have to be less than 3. So now that has to be less than 3. So with these compound inequalities, we now get some of these statements that have inequalities on both sides. So we end up getting two inequalities within the same expression. And at that point, we just have to go and we can still graph this like how we normally would, but we have to go down as far as -2, -1, 0, 1, 2, 3. And now we have to put an open circle at both -2 and at 3. And we now have to represent that it's all of the values between those. So if you have a different colored pen, you can draw a line straight across, or you can go ahead and put your thing over the top. Now, when I'm doing this just fairly quickly, what I'll end up drawing this like is it will look like this: -2, 3, circle, circle, that. And my students last year kept calling this the Baymax solution because it reminded them of Baymax from Big Hero 6. So if this is a helpful way for you to remember what your answer could look like, go ahead and think of it as the Baymax solution. Otherwise, you can still think through it logically as well and come up with the same type of drawing for your number line. Let's try this next one. All real numbers that are less than 0. So 0, we need numbers that are less than 0, or our numbers have to be greater than or equal to 2. So this is an or scenario, so we can have either option be true or both at the same time. Well, if our numbers are less than 0 or larger than 2, they won't be true at the same time in this case, but it does give us more answers that could work. So, oops, there we go. So let's go and we'll mark our 0. We'll mark our 2. I'll do this one with a different color. So it has to be open circle at 0 and numbers that are less than that, or a closed circle at 2 and numbers that are greater than that. Now, when you have inequality signs, when you have two in the same expression, you can still solve them at the same time if you need to. So for example, this next question, 2 is less than x plus 5, which is less than 9. Well, if we're trying to solve for x, if it was just that left half, we could go into subtract by 5. And if it was just the right half and the 2 part was gone, we could subtract by 5. Well, when we have the expression where both are true at the same time, we can just subtract both sides by 5. Well, 2 minus 5, that'll give us a -3, is less than x is less than 4. Well, that's easy enough. We can graph that. So we'll go from -3 to 4. We'll have an open circle at each and connect the dots. And that's what our answer can look like. Or for this next one, we can go ahead and add 3 to both sides, or in this case to all 3 sides. Come out with a -2 is less than or equal to negative x is less than or equal to 5. Now we need to get that to be a positive x. So we'll need to divide every side by -1. And this one's tricky because remember, when you divide by a negative, your inequality is going to flip directions. So this one will flip that way, and this one will flip that way. Our x will stay in the middle and will now be positive, and our 5 will now flip to being a -5, and our -2 divided by -1 will now be a +2. So we can now graph this new equation, and our smallest number is going to be that -5, our largest is going to be the +2, and x has to be everything in between them, including those 2 points, because it has the equal to line. So we can put a solid filled in circle at both, connect the dots. Here's one last one for us to solve. And this is an OR scenario, so we need to solve them separately. So first, on the left, we'll subtract 3 from both sides. We'll be left with a 2x is less than 6. Now I can divide both sides by 2, and x is less than 3. For the right expression, we can add 6 to both sides. We're left with a 3x is greater than 18. And now we can divide both sides by 3, and we'll be left with x is greater than 6. So now that we have our 2 different options, we can go ahead, make our number line. 3 is our smaller number, and x has to be the values less than 3 or smaller than 3. So open circle at 3, arrow going to the left. Or x has to be greater than 6. So at 6, we'll have an open circle, an arrow going to the right. And that's it. So if you have any questions, shoot me an email, and otherwise, good luck.